Okay, so good morning, everybody. This is a new episode of our internal seminars that are actually open to everybody. And today we have Zora Kovacic. Despite the name, she's Italian. Well, she's half Italian, half Brazilian. And well, she speaks many languages, as I was introducing her. And at the moment, she's a postdoctoral researcher at the Universitat Oberta de Catalunya. And well, she was like a nomad, like me. You know, she studied her PhD from the ICTA in Barcelona, but then she worked in the University of Bergen. She was in Stellenbosch in South Africa as well, and she was working with our very good friends Mario Giampietro and Silvio Funtovic. And of course, she has a very eclectic background, and she's been doing some very interesting work on circular economy in recent years. And actually, she published a book that I think is fundamental if you want to engage with the social dimension and more like sociological aspects of transition to circular economy. So for me, it's an honor to have you here. And the idea is that Zora is going to talk about her present research. And the idea is also to connect to the rest of the team and explore possible collaboration. One link that probably the most obvious link is with our H2020 project, Just Transition to Circular Economy, just to see. But of course, in Prospera, we have people who are working on sustainability and complexity theory and technology. That can definitely be like a good connection to Zora Kovacic. So after the seminar, please feel free to get in touch with Zora. And if you need like more clarification, or we want to establish like a more systematic collaboration with her, we can write paper together, writing proposal. Me and Madalena, we are in close contact with Zora, so there will be like development in the future. And I hope that she can visit Pontevedra with the family in spring or next year when there will be the opportunity to come over. Okay, Zora, so the floor is yours. Normally what we do is we listen to our speaker for around 30 minutes, maximum 40 minutes, and then we have an open discussion with questions. So our seminar normally lasts 1 hour and a half. This is more or less the duration. Okay, so welcome.
Perfect. Yes, thank you so much for the introduction, and I would absolutely love to come in person when we can. I'm going to try to share my screen. PowerPoint. I guess I have to share the whole screen, right? Okay. Is it okay? Yeah? Okay, good, perfect. All right, so what I thought I would do is that I wanted to present a bit my work in general, and then in the last part of the presentation, I will talk about the research that I'm doing now more recently, which focuses a bit more on innovation. But I thought I would give you a bit of context because I'm looking at innovation from, well, a very particular angle. So I will introduce this a little bit. Okay. So my main interest and focus is the study of the science policy interface. And in this, one of the guiding questions is to understand this relationship and when does policy turn to science? Why does it turn to science? And here there's different ways of reading this. So one can say, well, policy turns to science when it needs an answer to a problem, a solution to a problem, when there is a knowledge gap and it needs information that is missing. And maybe the example of the vaccines during the pandemic is one of those instances where a solution was asked of of science. And this way of understanding the relationship between science and policy is also known as the modern model, in which science speaks truth to power or to science. There's different interpretations of this relationship between science and policy, and yeah, I'm not going to go through all of them, but one more that I wanted to mention is that sometimes this act of looking for answers or for evidence or for truth from scientists or researchers plays an important role in policy, not necessarily because of the answers that are given, but because it legitimates the decision-making process. And these two readings are not necessarily contradictory, so I'm not saying that when science is engaged because it legitimates the policy-making process is necessarily corrupt. It's just that part of making policy is also what needs to be shown and what needs to be seen. So there is a part that is, performative, and that in a way reinforces this idea that science is a provider of truth. And this is a reading that I will argue, and well, you've heard this before from Silvia for sure, that is a very reductionist of science, because science doesn't always provide truth, or not only that. So in this vision, science is seen as a puzzle solver, and policy as applying the solutions that are provided by science. And in the in the ideal case, the solutions are optimal, they are rational, so they satisfy everybody, they don't create conflict, and this is one reason why you would turn to science for the solutions, because they allow to overcome situations in which there are winners and losers. If the solution is optimal, then everybody wins, in theory at least. What happens that this modern model, this ideal model of the relationship between science and policy, gets into trouble when we are in situations of complexity, or when we are dealing with challenges that can be defined as post-normal, right? And in these situations we have irreducible uncertainty, so science maybe provides partial truths, but not necessarily all the truth. There may be problems that don't have a solution, so this idea of solving the puzzle, some puzzles cannot be solved, and there may be legitimate value disputes, so cases in which there are winners and losers, and the conflicts that arise are legitimate in this sense, and the solution does not satisfy everybody. And this is typical, the situation of complex environmental challenges. Or at least this is the focus of my research. There is other fields to which this framework is relevant, of course, like health and many others, but yeah, my focus has been mainly on environmental issues. Yeah, so you have a few examples here of issues like, we can think of climate change, where causes are multiple and they're interrelated, and so here you have this complexity in which the impacts of different solutions or decisions or technologies that are being used may be uncertain. And we can think of I put the example here of the BPA, the bisphenol A, which is a sort of plastic, which is one of the, well, it's a chemical that is used for plastics. And this is one of the most studied chemicals. And there have been studies about BPA for at least the last 30 years. And it's also a very, very controversial issue, and one that still hasn't been, there is no agreement at the European level, for example, on how to regulate this. And so this is, I think, a very good example of the complexity of the fact that it's not a lack of science, of understanding, or of data, of case studies, which creates a situation in which the puzzle has no solution, but it's a matter of, issues that transcend science in a sense, and also that science cannot solve. No, there is this irreducible uncertainty here. And then we have solutions that may have unintended consequences, and well, just one example here can be nuclear energy and the whole issue of the nuclear waste management, which it wasn't, it came up later, right, as a consequence that wasn't foreseen. So in the situations of complexity, there can be two main approaches, let's say. One is trying to achieve the governance of complexity, and the other one, which is a bit more like post-normal science-based, is to go for governance in complexity. So in the first case, when we talk of governance of complexity, the idea is that this complexity can be governed through, for example, better models, more variables, more data. Later, there is this. Lately, we've experiencing this turn toward the digital transition. So more and more, there's this talk of big data and AI and algorithms, which are also means of governing complexity, more complex systems, right? And this approach is, I argue, a reproduction of the normal science paradigm of solving puzzles. The only difference is that now we are trying to solve more complex puzzles than before. There's different approaches here that are used, and this we can discuss. It can be a little bit controversial, but I put as an example multidisciplinary approaches, not necessarily because multidisciplinary or even interdisciplinary approaches were designed as a way to govern complexity, but because this is taken sometimes as a reference, as an example. This is how we could do it, right? We integrate different types of knowledge with the expectation that they will come together nicely and sort of fit together like the pieces of a puzzle or like an orchestra, which will give something harmonic out of it. And this is not necessarily the case. Same for the nexus thinking, which has been in vogue very much, and this was the topic of our MAGIC project with Madalena, where the idea is to try and link and analyze together things like water, energy, and food, and again, integrating everything and getting this vision, being able to characterize the complexity, so then when you can understand it, you can govern it. Or systems thinking sometimes follow the same line. Again, not necessarily, but these are techniques that are enrolled often in this mode of governance. And the alternative, which takes a different understanding both of complexity and of uncertainty, is this idea of governance in complexity. So complexity creates a situation in which the relationship between science and policy needs to be rethought and changed. So in this case, we may talk of complexity as irreducible pluralism in the knowledge base. This means that we may have different perspectives, and these are non-equivalent, so they don't necessarily fit together nicely and coherently. There may be contradictions, there may be controversies which are scientifically based, and this is also the type of evidence that informs policy, which means that the solutions that are found are very often temporary, local, contextual, not definitive, not necessarily optimal in the way that I was mentioning before. And so the general idea here, I can refer to this aphorism by George Box, right, where he says that all models are wrong. There is no way to characterize this complexity correctly, but some are useful. which means that the focus becomes on what is useful, and useful depends on the purpose, depends on the context, depends on the process. And so the idea is that instead of trying to look for truth, we try to ensure the quality of the decision-making process, considering different types of science. Okay, so that was my theoretical overview, and I've applied this to different lines of research. One that I've worked on quite a bit and was also the focus of my PhD was the study of how scientific evidence is used in the governance of complex environmental issues. I've worked a lot on studying uncertainty, and how it affects the perception of what constitutes scientific evidence and how it can be used in decision making. And lately, I've been turning more to the study of the role of innovation in environmental governance, which I'll get to in a little bit. And yeah, hopefully, I'm looking forward also to the discussion and input you may have on this. Okay, trying to look at time. So what I have is a couple of examples of work that I've done in the first two lines, and then I'll explain what I'm doing now. So for the first one, the role of evidence, and I've been looking especially at quantitative evidence, so data, numbers, metrics, whatever is used in the science policy interface. The example that I wanted to use here was of the circular economy, which I think is a neat example because this is, well, as you know, a relatively new policy that the first communication came out in 2014, and then the 2015 one, which is the little quote that I put here on the slide, became sort of the reference, the starting point, at least at the Commission level, for what the circular economy is supposed to be. And the basic idea here is very general, very generic, right? So we speak of an economy where the value of products, materials, and resources is maintained in the economy for as long as possible, and the generation of waste is minimized. And this is being very generic. You can fit different interpretations here or ways of going about implementing a circular economy. So one thing that was very interesting to me was that as this idea was being developed and as the policy was in the making, one of the first things that was done was to develop indicators for it. So here we go back a little bit to this point that I was mentioning before, the role of evidence as legitimizing the policy process. Because if you have indicators and if you have statistics, then you can, on one hand, monitor, understand to what extent the economy is circular and monitor progress and see if it's becoming more circular. But at the same time, these indicators define what the circular economy will end up being, right? So in the development of indicators, there were a lot of agencies of the commissions, the DGs that were involved, some universities as well. I will come back to this later with the example of the work that is done by the group of Zora Kovacic with material flow analysis. That was very influential here. There were two questions here. One is, when selecting indicator, the issue of what type of data is available, what statistics exist, which is an important starting point. And this drove a little bit the focus on waste management. But one of the ideas with the circular economy was to present it as something more than waste management. And so then comes the issue of, okay, but we don't have data about reuse and repair, for example, so how can these things be measured, and what types of indicators can be created to make this about not just waste, but about something more, about the economy. And yeah, what is interesting here is also how these indicators become also a way then of putting these ideas into practice, because then the member states will be asked to provide this data and to report on their progress on different indicators. So when all of a sudden we have a category here of indicators in the circular economy that is competitiveness and innovation, this means, and then we can get into the question of how do you measure this and how do you render them numerically, but also this becomes performance that is asked of the member states. And so this is a way of then governing circularity, right? So this is a bit the idea of measuramentality, where it becomes an instrument, a technocratic instrument of governance. So yeah, I guess I already made this point, but we can see numbers at once as the outcome of negotiations on how to represent society in its activities, and as consequential for putting in practice and acting particular realities. Now, well, I don't want to take too much time with this, so I think I will skip ahead. But yeah, I wanted to put here the example of, this is the material flow analysis that is used to for the Eurostat indicators to measure how circular the economy is. And what I think is interesting here is that this evidence that is used to supposedly inform policy doesn't necessarily inform policy. I think this is an example where we see that it provides this function of legitimating what is being talked about, but not necessarily, not always, of guiding action. Why do I say this? So this is a study of how circular the EU economy was. I think this was 2015 or 16, I don't remember exactly. So we see that 52% of the material flow that goes through the economy is food and energy. And what happens here is that most of it, all of the energy and most of the food or biomass, they are degraded through use. So their use is necessarily linear because of thermodynamics. There are irreversible processes, and this cannot be circulated or reversed. And then another 45% of this material input is construction material. And it goes into stocks. And this doesn't mean that it's impossible to reuse or recycle, but it means that in practice, for many, many years, it stays in stocks, right? We don't build buildings so that we can take them down by the end of the year and next year build them again. So in that sense, it's not circular in the immediate sense. And so this means that there are small fractions, small with respect to the overall consumption of biomass flows that are recycled, and this is the little green bit that you see go down in the circular part. It means that overall about 13% of the materials that go into the economy end up being circulated, right? So the circularity of the economy is 13%. Because of thermodynamics, I argue that this cannot be much higher. It can, of course, it can be improved, it can increase, but I would be surprised if it got to more than, I don't know, well, not much. Let's say that at least 80% of the economy is necessarily linear, right? So in this sense, now what does this evidence and this data show? And my question is, if the economy is mostly linear, does it make sense to, mostly linear necessarily, because of thermodynamics, doesn't make sense to invest so many resources and investments in thinking of how to make it circular. Okay, this is a little anecdote. I wonder. Well, let me know how I'm doing with time, because okay, thanks. But this was Herman Daly, which is one of the founders of ecological economics, and he was writing this in 1985. He was not talking about the circular economy. What he was taking issue with was the fact that the monetary flows in the economy are represented in a circular way, right? So if any of you has studied economics, maybe you have seen this type of graphs where you have the firms on one hand and the workers in the other, and you see the wages going one way and then the consumption going the other way, and it's a circle. And Daly took issue with this and said you cannot represent the monetary flows in a circular way because the material economy is not circular. And so I wonder how he would react to the idea of a circular economy, right? And he thought this was so absurd that he says, one might as well ask an engineering student to explain how a car can run on its own exhaust, or ask a biology student to explain how an organism can metabolize its own excreta. And this is the thermodynamic view of, does this make sense scientifically? A more maybe moderate critique or reflection about the circular economy is that there is, of course, recycling of many nutrients and components and elements, but this often is very, very slow. So there is the example here of, it takes 9 days for water to cycle through the atmosphere, while it takes 37,000 years for the oceans to complete a cycle. Phosphorus takes 2,000 years to cycle through the soil, and so does nitrogen. Carbon dioxide takes 4 years to cycle through the atmosphere, while atmospheric oxygen takes 3.7 million years. So we are talking about very, very, very slow processes if we want to think in circular terms. And the point here is that, why is so much of the economy, over 80%, linear? Because this makes it possible to accelerate economic growth. So if we are talking about a circular economy, we are probably talking about a very, very slow economy, which may be a good idea. But the point is that for the Commission, the circular economy is an economic growth strategy. So again, maybe we have to think a little bit more about this. All right. So the point of showing these examples and this evidence, which is part of Eurostat and it's part of the knowledge base of the policymaking, is to say that the science and the scientific evidence that underpin this idea, they can be seen a little bit as a 16th century map. And these were maps that they didn't aim to be objectives, right? In the maps you would see monsters and sometimes unicorns or rainbows. And so the maps, they reflected very much the fears or hopes, aspirations, whatever, of the author. And I think this is a little bit what the circular economy is, including the evidence that is used to describe it. It reflects what maybe some aspirations are. And yeah, we should think of whether this describes some sort of reality or not. Yeah, okay, I'm going to leave it here. This is the book that Maria was mentioning earlier. Right, so then another example that I wanted to use, I'll try to be brief, is on the role of uncertainty and how it affects, again, the science policy interface. And here I wanted to talk a little bit about a case study that I worked on when I was in Stellenbosch in South Africa. And here we're studying slums, or informal settlements, the favelas, whichever term is more familiar to you, which are typically, I think, an example of governing something that has very high uncertainty, starting from the fact that often local governments and municipalities don't know how many people live in these settlements and under what conditions, and so decisions have to be made and measures are taken without full information. So the example here is an illegal settlement in Stellenbosch, which was created in 2006 by invading municipal land that was not destined to residential use. It was taken by force, and that's where the name comes from. And then, quite a few people moved in, and when it was a few thousand people living there in 2012, there was the first exploration report that was done. So people from Cork, from this local NGO, went in and counted the amount of people living there. This was supported by the municipality. And yeah, even though it's not allowed, at some point you have to do something when a lot of people start living in the settlements. So just to give you a location, this is South Africa. Stellenbosch is about 40 kilometers from Cape Town. So this is Western Cape. And within Stellenbosch, this is where Nkanini is, the settlement. It's relatively close to the center, maybe half an hour walking. Okay. What we were studying here was the energy needs of the community. What happened is that the Nkanini community, they asked to be connected to Eskom, which is the national electricity provider of South Africa. And one response to this was the creation of this iShack project, a local NGO that provided solar panels that were installed on the rooftops of the different shacks. The solar panels were provided for free, and what was asked of the households that had this was to pay this monthly fee of 150 rand, which is about 10 euros a month, maybe a little bit less now because rent has gone down. Anyways, the point is, it's not a very high fee. But it's for these households that are very, very poor. It's well, it weighs a little bit. It's about 10% of their income, and this fee is paid because, for example, there can be little repairs that need to be done to the solar panels, or if the battery runs down because it doesn't recharge for a few days, then somebody needs to be there. So there needs to be someone that lives in the settlement and that provides this maintenance service, and this is how they are paid, basically. The project started in 2012, and then by 2015, when we started the study, about a bit more than 60% of the households in Nkanini had it. But in 2016, also the project came to a halt. It created a big conflict, and basically some of the residents vandalized the shack where this was hosted, and this was a big surprise to the NGO. And how why does this happen? People ask for electricity, and then when this is given to them, it becomes a conflict. And so my argument here, and what I will try to show, is that this is a case of poor management of uncertainty. What was considered was the technical uncertainty. Here in the picture you see some of the solar panels that were installed. What was considered was the technical uncertainty. So this was taken as a technical problem, a practical issue. People want electricity. The problem that needs to be solved is how to provide electricity, and the experts can do that. They construct a solar panel. There are other types of uncertainty that were not considered, one of them being methodological uncertainty. And this refers to the fact that the supply of electricity, some amount was supplied, and who knows if this is enough, if it meets demand or not. And this is a difficult question to answer. For one reason is because the population was growing very rapidly, so it doubled between 2012 and 2015, which means that the demand also goes up, but it doesn't go up linearly, right? Because depending on the end use of different energy types, they don't grow in the same way. So something that changed. It's not only, you can see, not only the amount of people, but also the shape of the population pyramid changes, which means that the household composition changes. In the beginning, there were a lot of adults, single people, one-person household living there. And then in time, they start bringing their spouses, their kids. And so it becomes distributed differently. So there's more households of 2 people, 3 people, or more. What does this mean? That for things like paraffin that are used for lighting, once you light the room for one person, you light it for more. So there isn't a clear trend there in terms of increased consumption depending on people. But when it comes, for example, to gas, which is used more to cook, then if you have more people, you will use more energy. And so depending on what we are talking about, the household composition change impacts differently. And this is something that cannot be foreseen and modeled beforehand, of course. But then on top of this, we made the calculation of how this may change, looking at the change in household composition, and we got it wrong. Because paraffin increased by less than we were expecting and gas by a lot more. Because another factor that comes in is that when the solar panels are introduced, there is a change in consumption habits overall. So once people have the solar panels, they don't need to use as much paraffin for lighting. And paraffin is multi-use. They use it for lighting, for heating, for cooking, for many things. But if they don't need to use as much, then they prefer gas. And then all of a sudden, gas consumption increases a lot more. So this is an example of, I guess we can say, complexity, which cannot necessarily be modeled. And this is one source of uncertainty. And another one, which is very important, is epistemological uncertainty. And this has to do with, well, let's say how the problem is defined. So one thing we found out, when we were doing the surveys, we asked people if they had electricity, and they would say no. And then we asked if they had solar panel, and they would say yes. So we learned that solar panels are not electricity, and they're not. They're right. Because they don't give the same service, they don't have the same performance, right? They can only be used for some light bulbs and maybe for charging small things like cell phones, but the electricity provided is not enough to have a fridge on or a TV. So it's not the same as I asked for ESCOM and then I can plug in many things, right? They're weather dependent, the battery may run out, so it's not equivalent, it's not the same. But more important than this, something that, wasn't clear or was overlooked maybe, is the fact that the residents of Encanini, they were asking for the formal recognition of the settlement. And one way of getting this is to be connected to ESCOM, because that means that you are officially a neighborhood of the city. And once they got the solar panels, this became very, very problematic because they thought, okay, now they think we have electricity, they're never going to connect us, they're never going to recognize us. And so this is something that has nothing to do with how the panels work or how the demand evolves, but creates, what I call epistemic uncertainty. And it goes directly, why was this not seen or considered? Because it's directly in conflict with the priorities of the municipality. Municipality does not want to recognize these informal settlements, and understandably, because they will be coming up all the time. And some decisions about this also go beyond the jurisdiction of the municipality. So I'm going to wrap this up, and clearly we know this. The technological solutions do not address underlying social political challenges. And this is, an example of how uncertainty affects decision making, but it's also, I would argue, a case of the politics of uncertainty, right? Of what type of uncertainty one decides to take into account. And it's not clear. It's also part of a decision to say, well, this is a case of technical uncertainty, and this is how we're going to solve it. And this is where the paradigm of science speaking truth to power fits very neatly. But if we start talking about epistemic uncertainty, then it's not just a matter of science and technical solutions. And then we need a different paradigm. And then how to make a decision becomes more complicated. And so this is why sometimes it's not convenient to expand the understanding of uncertainty. Okay, last part. Sorry for being a little bit long on this. But so this is the research line that I'm working more on now, that I'm developing now. And I'm looking at the role of innovation, again, with this perspective of how does it impact the science policy interface. From this point of view, again, we can see science as the puzzle solver, as the provider of solutions. And in this case, it's a very specific type of solution because it's often in the form of technologies. Well, innovation, of course, can be many things, and it's spoken as in many different ways. So there is in policy a lot of mention of social innovation and whatnot, but the main role that I see in understanding the relationship between science and policy is of innovation as providing solutions and technical solutions. And this changes a little bit the role, according to well, Chettil Rommelveit, the role of science, because it's not just about explaining reality, providing truth, but it also participates in creating reality, right? Because innovation and technological innovations can do things. And well, now there's a lot of talk about virtual reality or expanded reality or whatnot. And so it's a little bit, it changes a little bit this relationship again between science and policy. I think that innovation has a very important role because it solves this Gordian knot of making difficult decisions, right? When you have the sort of blade over your head, me being the decision maker, and I have to decide on something that is very difficult, that I don't have a solution for, or that clearly creates some trade-offs and some disadvantages. For some people, if I can get out of this difficult decision and have an innovation, a solution that says, no, don't worry, we can make everybody happy, we can create a win-win situation. This, for decision making, for policy making, for the political negotiation, is very important. The innovation, what it does is to provide a way out of lock-in, at least in potential. Maybe we're talking about the future. Maybe we're talking about, well, let's invest in innovation because we have now a difficult situation, but we will be able to overcome it if we start innovating. So it's a little bit different because it's not providing a solution that is necessarily in effect. It can be just an idea. Yeah, and I have an example of this. This is a case study we worked on with Madalena on biofuels. And that hopefully someday we'll get to write it down and publish it. We were looking at the biofuel policies of the European Commission. And we can say this is a type of innovation. What happens is that the first generation biofuels, right, the ones that were produced from food or sugarcane or corn, later on became the bad solution, the evil, the problem, right? Because they compete with food, because they created an increase in food prices. So this is what was seen first as a solution, then became a problem. And so then for the policymaker, when we're talking about the transition from the dirty energies, the fossil fuels, to the renewable energies, this is a very sticky point because electricity substitutes for some uses, but fuel cannot always be substituted. A lot of transport is very much dependent on fuel. So there needs to be a solution here. This is an example of the Gordian knot that needs to be solved. So when this innovation becomes a problem, the policymaker is faced once again with this difficult decision. So then what happens is that we start seeing talk of second generation biofuels, third generation biofuels, so fuels that will be made from recycling used cooking oil, for example, and all sorts of things. And what is important and what is interesting here is that a lot of these new generation biofuels, these technologies, they don't exist yet. Or they are in experimental stage. So the point is not that we have a solution. The point is that we have something that can make the transition, to clean energy possible, and that makes the life of the policymaker easier. And so what is important in the science policy interface is the idea of the biofuel, of the clean biofuel, of the good biofuel. We don't do the bad ones, we'll do the good ones, we'll invent good ones. They will come into existence at some point in the future. They don't need to exist for this relationship to work. What needs to be there is the promise that a solution will come. Okay. And this is my current project, my current postdoc project that I'm doing here at WAC. And I'm looking at innovation as basically a mode of urban governance applied to different case studies: the circular economy, the digital transition, energy transition, and the superilles, the super blocks, which we can refer to as just transition. For now, I'm working on the circular economy case study, and the other three I have to develop in the future, but I wanted to mention them all just for everybody to have an idea. And I've started half a year ago, so I'm not very far along in this, but I'm trying to develop both the case studies and this idea of governing through innovation as something that changes this relationship between science and policy and creates a new mode of governance. So very, very quickly, because this is like preliminary and I'm running out of time, is what I'm seeing is that this is a figure that was taken by a communication from the municipality of Barcelona, where they represent the different types of innovation that they want to support. And so you can see that innovation is explicitly many things, because there's talk of, again, the digital innovation, the social innovation, democratic innovation, social economic innovation, business innovation, everything. And everything is supposed to come together and contribute to urban innovation. So again, we see this idea of the orchestration, the idea of everything fitting together nicely and contributing harmoniously to the goals that we want to achieve. And I think, very interesting. I think the insistence on the fact that, of course, it's also social, and we're not talking just about technology, even though when it comes down to practical problems, it is the technology first what is given preference. And then more specifically, when we speak of environmental challenges, some of the narratives that come up is that innovation is necessary or is important because it is a response to the existential threats that we are facing, like climate change, like biodiversity loss. So the environment is called in as, one of the situations, the lock-in situation, right? That really we need to break from the unsustainable path that we've been on so far, and this is why we need innovation. This innovation also needs to be disruptive. So we go back to some very economic-based way of thinking about innovation, even though it's supposedly social and whatnot and many different things. But when it comes to it, it's framed as disruptive and seen as very desirable because it's potentially capable of providing urgent responses, right? These existential threats, they're urgent, they need to be solved now. And innovation, it is hoped for, can provide this immediate solution, unlike economic growth, which is incremental and is gradual, and it goes too slowly to be able to respond to these very urgent threats that we have. That was it. Okay. So this is a little bit my framing, and I leave here my email, and if in case you want to reach me, and sorry for going a bit over time.
No worries. We are flexible. Thank you. Thank you very much for the, you put on the table some super interesting topics, some disruptive theoretical framework, and they are totally connected to the kind of theories and work that we are doing in both Prospera and Just to See. Well, we can open the discussion. Just very quick points. The first one, that what you say about Stellenbosch. I'm very close contact with the UCT in Cape Town. I've been working since 2015 there, so I know Stellenbosch as well. And your work resonates a lot with my work and my PhD and what I observed in Bolivia and Bangladesh with the solar panels. And yes, basically, I saw the same mechanism of reinforcing unequal relation and inequality in general. So that's I'm happy because basically you confirmed what I observed. And then the second comment is more like a question that we just hopefully getting rid of a tremendous pandemic, getting into a more like a serious trouble with war. And this moment was clear because we really saw the lack of trust of a portion of population in science, no? And then we have this polarization between anti-science sentiment, feelings like anti-vax, people like being critic about the way science is used, legitimate some action, no. But on the other side, there is also this tendency to say, okay, no, we need science, and science is the only solution. So this scientism, no, science as an ideology, or even like a religion, like the religion of economic growth. And as a social science, or like converted social science, I felt a little bit responsible because for years we have been saying science is political, science is not providing the truth. We have to be careful when we're using science to legitimate something. And I found in a situation in which I lost the compass. No, what we do in this situation, we've been like criticizing science for years, and now we are in a situation which actually people are using our arguments to destroy science and to have like anti-science position. So what do you think? What is the solution? Or probably this is complex, or maybe not. There is no one solution, but maybe like a guide to navigate this very complicated and complex time. Just very quick comment, and then we open the debate.
Yeah, of course. Well, this became a very big debate after like Brexit and the Trump election in the STS community, and Latour famously had a change of heart after being the anthropologist of science and social construction of science. His whole career, all of a sudden, he had the same like existential crisis and said, no, wait, I didn't mean that science is just fairy tales, right? So yeah, well, and there's still a colleague of mine from Bergen, Chetil, he just published a book on post-truth a few months ago, which I think is fantastic, exactly on this topic. I can later on pass the reference. But anyways, my opinion on this is that I think part of the problem of the crisis of trust that science went through and is going through is that the idealizing science, I think, backfires, right? It's creating an idealized and unrealistic image of what science can do doesn't work. And this is why we say science doesn't have all the truth. And this is not the same as saying science is the same as astrology or reading, I don't know, what do people read, the intestines of dead animals. It's not guesswork, right? It just means that you don't have complete information. There are some uncertainties, there are some contradictions within science, and it doesn't make it not valuable, right? It just means, I think that instead of trying to create and uphold the idea of science as if it were like the blue prince or the ideal princess from some fairy tale. That's the problem, right? And so the response also, I think, no, to this post-truth debate of saying no, but science really does provide the truth. I think that's not helpful. I think what is helpful is to say science is extremely useful, and because it provides a systematic way of looking at things. It provides, it's a way of knowing that is very specific and that is different from other ways of knowing. And so it's important to recognize what it is, but not to expect it to provide all the solutions, because it doesn't.
Okay, fantastic. Okay, now we can open the question time. There is Tess and then Miguel. Tess, please.
Hi, thank you for such a wonderful presentation. I was sort of thinking about your case studies all in the three parts of your presentation. I think there were three, right? All in relation to each other. And I'm sort of wondering if I can ask you to discuss your sort of theory of the relationship between science and policy a little bit more, because at the beginning of your presentation, you pointed out that science has basically, in your sort of understanding, two relationships to science, either to policy. Science has two relationships to policy, either legitimizing or providing truth or speaking truth to power, or providing sort of useful knowledge, right? Useful, true knowledge to policy. But it strikes me that there's a really important sort of reverse dimension of that policy provides a pretty strong sort of shaping power to science and the kind of knowledge that's out there. And that's deeply relevant to the case that the circular economy discussion that you're having, sort of like, why are we talking about circular economy? Why doesn't the very sort of institution that is sort of advancing circular economy as the solution, understanding the science about circular economy? But the European Commission, of course, serves an huge agenda-setting role around circular economy and asks all sorts of scientists to, in fact, tell them that circular economy is possible in all sorts of different ways and how it's possible. And then this brings in, I think, the stuff you're working on now, and these ideas of like the sociology of expectations and looking towards the future and how we govern with innovation. And the OECD is certainly doing this, and the European Commission is doing this. And we can think about these two institutions as, like, of course, they are economic institutions. They are institutions that historically have served the purpose of doing economic policy. They're not doing social policy. They're not doing anything else. They are trying to create particular kinds of economic relations in the world, right? And so the ways that they are setting agendas about the scientific sort of like about the circular economy in these ways sort of produce the kinds of science that tells them it's possible, and that then sort of make the promises about the future that says maybe we can innovate our ways to the circular economy being completely possible. So it strikes me that there's these sort of connections between what you're working on now and what you presented as far as like this more sort of like, why are we doing this question about the circular economy?
Yeah, thank you for your question. I agree with you 100%. I started with these two views, but they're obviously not, there's many more that I wasn't aiming to say, well, this is all the ways that you can interpret the relationship between science and policy. And like you say, there's absolutely a reciprocal relationship there, or we can, in SDS terms, we can speak of co-production of the science and the policy. And yeah, like you say, there's, funding for research plays a huge role in a lot of what we end up doing. Even if I take a critical perspective, at the end of the day, I worked on a project on the Nexus because this is what the Commission wants. And it was a Commission-funded project, right? So yeah, 100%. I agree with you there. And and even I think I forgot to mention this, but my case study is now on innovation. I'm looking at Barcelona as my case study, and Barcelona is very proud to say that they align their policies to the European Commission. So again, you have this, why are they talking about the digital transition and the green transition? Because this is the European Green Deal, and Barcelona wants to be an example of putting whatever the Commission is talking about into practice. So again, we see this relationship very, very much. But just one thing that I would add to this, because sometimes so clearly there is a co-production between what science can do and yeah, the funding legitimates the science, and then the science legitimates the policy. So it goes both ways, like you say. But I wouldn't want to argue that this necessarily closes the debate. And I say this, let me give you an example, because otherwise it's not understandable. In the last 2 years with Silvio Funtovic and Roger Strand, we've had a small collaboration with the European Environment Agency. And we've been working on exactly trying to introduce this framework of the governance in complexity in, some of the work and reports of the EEA. So this is not the mainstream narrative, and there is some interest, even though this is an institution, an agency of the Commission, there is some opening there. Yeah, which sometimes it's very complementary to work that they've done, but sometimes there's a little bit of friction with some of the takes and recommendations and whatever policy briefs that they've published before. So it's been very, very interesting. And there too we see this this relationship again, right? Because there is. So we've had a lot of conversations about post-normal science and governance in complexity. And yeah, this is interesting. This is relevant to our work. Great, we'll do a report. Now, can you provide us statistics and evidence for it? Because you have, this is why they coexist, I think, these different roles. You have this need to legitimize with what is perceived as science, which is hard science, which is data. Right? Even when you're talking about uncertainty and post-normal science, at the end of the day, it's like, okay, but then provide case studies, but then, provide something empirical, because it needs to look like science in the normal and classical sense, right? And we are being funded for this, not much, but I mean, so there is a shaping, a lot of shaping of what goes on in science through the policy-making institutions, but sometimes there are openings, I think, also for alternative and critical views. They're funded anyways, and then you are in this weird space where you try to do something different, but you're asked to do it in a way that can be understood as the normal way of doing it.
Yeah, this happened to us all the time when we are presenting degrowth and post-growth to the University of Vigo. They're asking for graph and numbers. Yeah. As if saying that it's impossible to grow in a finite planet would need some evidence, Okay, Avi, the next one was Miguel.
Yes.
If you want to make a question, please raise your hands.
Yes. Okay.
No, as I'm talking to the others. Okay. Miguel, please.
Yeah, thank you, Zora, for your presentation. Very interesting. I have a comment and a question for the first part of your presentation. I agree with you completely that metrics and indicators are very important because they may bias the result, any analysis, and as a consequence, policy guidance. And I have been working on that. I have published some papers on that line of research. So I agree with you completely. But there was something that I didn't understand, because, for instance, in your example, you were talking about material flow analysis, and you say that that is not useful for policy guideline, because, for instance, in your graph, the circular part of the material flow is really low, and it is difficult to increase that. From my point of view, that is very interesting. It is very useful for policy guidance because the measures should be there then that you can try to improve something in terms of circularity by looking to recycling, let's say, or reusing. But the most important thing, or where policy should put all the emphasis and effort, should be just at the beginning, just by reducing the use of resources coming from nature. So from that side, that is a very important policy guideline. That is a very important message. So I didn't understand why you say material flow analysis is not useful for policy guideline. So I would like to know something more about your position.
Thank you. Of course. There's a few things I think that can be said about material flow analysis. What I think is interesting is that this was chosen as the statistic that went into Eurostat to measure circularity. It's an interesting choice for many reasons. One is what I was explaining before, is that according to this way of accounting material flows, the level of circularity is very, very low. So it's, what does it mean to speak of circular economy when we're talking about 13% of the material flow? But one could also say, well, you know, what are we measuring with material flow accounting? Because all the materials that go, that are used in the economic process are measured in tons. And this is why you have construction materials that make up almost half of it, because they're heavy. That doesn't make sense, you know, or maybe, and this is also part of the policy discussion and part of the statistics. It's not that it's not there. The issue of rare earth materials. So maybe what we need to focus on is the very expensive to get materials, even if they're not very heavy in tons. And so they're a little bit irrelevant, let's say, if we take this material flow type of representation. But economically, that could make sense. Or there is the whole issue referring to uncertainty of the hazardous materials. There are things that you don't want to recycle. And then these are also not very visible in this type of accounting. What you say, I think, is one of the interesting points of the circular economy, which has to do with what sometimes is called eco-design and trying to use less materials to begin with. And I mean, to clarify, I critique how this policy is thought of and put into practice, and the type of evidence that goes to support things, because some of this evidence contradicts, I think, what the policy is trying to do. But it doesn't mean that I think the circular economy, all of the ideas there are crazy or shouldn't be done. There's obviously a very important environmental benefits from recycling and using less materials. So all of this, I think, are very good ideas. But my issue is a little bit with the framing of this and the purpose of this, and saying that this is an economic growth strategy, which I don't know if it is. I don't think it needs to be. It doesn't make it not valuable if it doesn't lead to economic growth. Like I said, there is some valuable ideas there. But the problem then with eco-design is, how you measure it. What type of indicators can you use? And there is one of the knowledge gaps. And so this is something, so then an indicator appears in this dashboard that is innovation, which is patents. And the number of patents about whatever is taken as a proxy for innovation for the circular economy. And that's an interesting one too. Right? And does that mean that we're designing things better so that we use less material and less goes into waste? Who knows? This is where I come in with, or try to come in with a bit of a critical eye, not because I don't think this should be done, but I think that, well, for many reasons, political and of governance and institutional and etc., things are done the way that they are done, and this could be improved. Is that an okay answer?
Yes, and then and actually we have internally in the group we had like a very animated debate about the nature of innovation and how we measure it. No, I was like I wanted to write something about we need to disrupt the way we measure innovation, because in the innovation scoreboard of the European Union there is also like an eco-innovation scoreboard of the European Union. Basically, you have things like patents that don't discriminate if this is a patent like of a weapon patents or a cure for cancer. Or you have such a crazy things like a number of PhD students per person in country, and then you define as Sweden is the most innovative country in Europe, like not taking into account all the work that is done in workshop and innovation is like a frame is something that is for the markets and produce impact on the markets, neglecting all the study that say that actually a great deal of innovation is done not in the market, not for the markets, and the market appropriate innovation in many cases like for free. And we have a dimension of part of our work is about common-based pre-production, which is like coming up with different ideas of ownership, property, and actually also even neoclassical scholars or evolutionary economists like Giovanni Dossi did famous papers in the 90s about the importance of getting rid of patents as a way to measure innovation and so on. So innovation is crucial. And then there is like the third level of Prospera, which is Work Package 3, that is about the relationship between science, technology, and innovation system, like institutions, like Research Center, the CSIC in Spain, or the UK Research Council in the UK. And what is this, the relation between the discourse of reproducing the connection between science and economic growth? No, maybe that one can be like a potential ground for collaboration with Zora. Okay, but I see that Tess has her hand raised. I don't know if she wants to do another question or comment.
No, sorry, I just never unraised it.
Okay. I don't know, any other question, comment? No? Maddalena, I mean.
Yes.
Say something or comment something.
No, I was, I have been working with Zora last year, as she said, and we have these pending papers. It's my fault anyways. And no, I was curious about the last part because I was not aware of your last work. And about I am curious about the work that you are doing also, and maybe you can also comment on this, on digitalization of innovation. Which perspective are you trying to explore on this?
Okay, yeah, I can tell you what I would like to do, because this is one of the case studies that I haven't started looking at yet. But it's my interest is also to understand these different policies like circular economy and the digital transition, how they are applied and how they trickle down at different scales. So it's something that has become, or is becoming quite big at the European Commission level. And then I see Barcelona, the Ayuntamiento here, the municipality, also embracing it. Also the Generalitat, we're talking about the digital Catalunya, embracing it. And so my interest is to see, what does this mean? What is being done? which is, yeah, it's not obvious, to me at least. Then in practice what happens, right? Because there is this idea of, digital turn and where, in what sectors, and what does it mean, and why is it a priority for policy? And one of the things, one of the aims that I know that the municipality has is to make Barcelona the 5G hub of the Mediterranean. And why? What is the benefit of that? Is a little bit what I want to look into, and with a big interest in what is the role of innovation here. Why is this being done? Is it because this is a type of innovation that we want to support, and because, again, no, it comes with all these expectations and imaginaries and ideas that this will bring solutions. Barcelona is also the city of the CDIM, right? So this resonates. This is interesting too, I think. It resonates across the political spectrum. So it's, yes, very often very much related to the market and economic growth. But then we also see the CDIM and digitalization as a way of implementing direct democracy. And this is embraced sometimes enthusiastically also at the left end of the political spectrum. Yeah, it's these are the reasons why I'm interested. I don't have more details for now because I haven't gone into it yet. Yeah.
Thank you, Zora. And I want to just have one of your comments on the fact that usually we have this. The innovation is very often assumed as something technical. No. There are no, are not assumed as social innovation. And in Just to See, we are trying to make a step forward as social innovation, proposing something different in how to frame a just transition, no? What is missing? What is your opinion, and how you dealt with this gap in your previous experience with policy making, no?
Yeah. Yeah, this is something interesting too, I think. My experience, for example, going back to the little collaboration that I've had with the EEA, is that they love to talk about social innovation. And it is high on the political agenda. It's not something that is not there. And we can interpret this in different ways. But there is a political priority in this not leaving anyone behind and in the just transition. So all of this is, I think, falls in well with a lot of the political discourse that we see right now. But one thing is the rhetoric, and a different thing, I think, is where the investment goes into and where the expectations come from. Also, my perspective comes a little bit from looking at environmental issues, right? And so when we talk about a lot about climate change and how to solve it, a recurrent topic of conversation ends up being, well, let's stop using fossil fuels and let's go to renewable energies. And how do we do that? Mainly, not exclusively, but mainly it's technological solutions. And then, yes, of course, it would be wonderful if there's also social innovation and people are on board and they come up with their own energy communities, and this is fantastic. But the policy focuses a lot on funding and supporting the technological solution. So, yeah, from my point of view, focusing mainly on this environmental issues, this is what I see that the focus is, with always this rhetoric that the social innovation is super important, and of course it has a place, but what does it mean? And this goes a little bit back to this issue of if this is to make it into policy, it needs to be backed up by evidence. And so how do you measure social innovation and what it does? And if you cannot measure it, then yeah, it's important, but somehow it becomes sort of less present in the practice, right?
Yeah, some sort of second class kind of innovation.
Or something that in any case has to be proved. Thank you.
I see that there is no other hands raised. I assume that you will join me and Madalena in the ESST conference in Madrid in July, Zora.
Yes, I want to come, yeah.
Okay, because we have, we'll just put it on the chat, we have I'm organizing a sub-plenary on innovation and post-growth. So there will be Sandra Boni from Valencia, Andrea Jimenez from Sheffield, and Adrian Smith that worked a lot on Fab Labs and Makers Community. And I mean, if you are more than welcome to join the discussion, there will be an open panel, and we will invite also by people from the audience to contribute. So. Okay, so thank you very much, and I hope that we can keep in touch, and maybe we can have another call, me, you, and Madalena, in the following weeks to follow up and to start doing something great together. It can be like writing a grant proposal or a paper, and try to do something like more systematic together. And I'm looking forward to having you here in Pontevedra. So let's talk about that as well. So thank you very much. Thank you everybody from Prospera and external people to join us. And we will upload the recording on our YouTube channel so you can circulate and share and disseminate the seminar. Bye bye. Grazie mille.
Bye.
Ciao.
Thank you all. Thank you very much.